I've been in this industry now for, I think, close to 30 years almost. Last 21 in Microsoft, where I'm currently in the corporate standards group. So we are the people that are looking at cross-products fundamental standards. So anything that you would define in NIST, in ISO, in Sensenelec, things that help every technology company and that are not related to a specific product. And I moved to that group from our cloud engineering group in Microsoft, because a couple years ago there was this new project started in Europe where everybody believed it could become an Airbus style of clouds, proclaiming that they are defining new cloud standards for data centers. And well, as soon as I joined the group that worked on that problem, we figured out nobody really wants to define a standard how we move electricity in a data center. We have plenty of those to choose from, but it's all about how we move another fundamental resource in data centers. How do data move in a trustworthy way? How can we share data? And that led to engagements in the industry with iSHARE, with the International Data Spaces Association, with Gaia-X, with Sensenelec on the JTC 25 for Cloud Data and Edge, with various other organizations. And so today, I'm part of the Eclipse Data Space Working Group. I'm a committer in the data space projects like the EDC, working group lead for several working groups in IDSA, and everything leads to one goal in the end. We need fundamental standards, because somebody asked the question 2 sessions ago about the spaghetti of data spaces. Great picture. I think of it more like a soup. We have this primordial soup. A lot of organisms are swimming around, and we need to see where it converges. So let's have a look about what this question of interoperability of data spaces mean, because I think that there is a fundamental misunderstanding in the room. And I think it originated with the German name for data spaces, because in the original research from Fraunhofer, they called it Datenraum, literally meaning a room for data. But a room has a problem that you cannot be in multiple rooms at the same time unless you go into the 4th dimension. And so you have to go into a room and leave the room to go into another room. And when we think about data sharing, that is not the reality of data sharing that we see today. The real valuable use cases start emerging when we are looking at data from multiple industry, from multiple domains, interacting with each other. So think about data for the CO2 footprint of a product being produced. You will need data from energy data spaces, you will need data from manufacturing data spaces, from mining data spaces, from all kinds of resources. Considering that as individual rooms that you need to get in and out makes the thing really complicated. So the better way to think about this is just say a data space is a context of trust. The context of trust is being built for one negotiation of data usage, but what trust means might be different for each ecosystem that I need to interact with. So that puts the party that wants to receive the data at the center of the interoperability question. So the question is not whether a data space like Catena-X is interoperable with a data space of Iona-X, which is a travel data space. The real question is the participant that needs data from both data spaces. Is that organization compliant with the rules of one data space as well as with the rules of the other data space? So doing that means that the real interoperability question is not whether Catena-X is interoperable with Iona-X, but how difficult is it for me as a participant to keep track and follow all the rules of all the different ecosystems. Because as this starts growing, I will probably end up as a somewhat medium-sized company being hundreds of data spaces that I need to interact with. As a multinational company, thousands of data spaces operating in hundreds of different legislations. That is a very complicated interoperability matrix. So the way we look at this, we say we need a certain interoperability inside of a data space. So between participants, that's a very low level interoperability. But then there is a this intra-data space interoperability question that is basically like, what makes it possible that I can share data between one initiative and the other initiative, or that I can consume data from both initiatives? Well, that is all about how interoperable is the negotiation of trust in those ecosystems. So that's where I'm very happy that we are working with organizations like iSHARE, because it's not just about standardizing the technology underneath that moves the bits from one end to the other. It's about standardizing the way of how do we negotiate trust? What are the vocabularies that we use to express that trust? Because that is ultimately the interoperability between data spaces that so many people talk about. So the way that I look at this is that, oops, sorry, forgot one slide. So we have two models on how to look at interoperability, and I see the slide color, unfortunately, with the copy and paste has changed. So sorry that there is white on white. There are two interoperability frameworks that we use to look at. One is the European Interoperability Framework. The other one is from the ISO 19941. And basically what those with very good eyes can see now that with white on almost white is that they have very similar layers. There is a technical layer of interoperability. On top of that technical layer sits a semantic layer of interoperability. So do the words mean the same thing in two different organizations? And on top of that, they have two more layers that are constantly being ignored in the interoperability conversation. One is a business process interoperability, and above that is legal interoperability. So let's take the example of a passport or a driver license that Gerard likes to use so much. I'm Austrian. I have an Austrian driver license. If I would drive his car, he kindly offered to loan his car to me for a day, then I can drive in the Netherlands because certain things happen. If I show my Austrian driver license to a Dutch police officer, he can technically read that driver license. He understands what is written on my Austrian driver license because there's a semantic model that says point number 1 is the name, point number 2 is the surname, blah, 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 year of birth, and so on. But on top of that, there is interoperability of the business process. The business process is very simple. I take my driver license, I give it to the police officer, that was the business process. And above that is legal interoperability. Because we are all part of the European Union, we accept each other's driver licenses and so on. And in the conversation that is happening today in the various data space organizations, unfortunately, everybody thinks that all interoperability needs to immediately be pushed down into technology. It's the problem of this bottom layer, the technical layer. But interoperability happens in all 4 of those layers. So, sorry again, I don't know what happened to the colors here. Something changed when the slides were copied over. So in the technical layer, we need new elements, protocols that enable us to exchange the information needed for data spaces. I like to reference this in a comparison to the internet today. At some point, Tim Berners-Lee has developed what we call the World Wide Web today. The original idea was find a technology that will enable researchers to exchange information in a way that it can be linked and that it can be rendered for human consumption. So the HTTP protocol was invented to transport data from A to B. And a semantic model was invented, HTML, that told the recipient, hey, this is to be rendered as a headline, this is to be rendered as a table, this is to be rendered in italics, this one is to be rendered in bold, and so on. And at some point, we realized this is not enough. There is a problem of an attack of the man in the middle if we only use HTTPS. We need to create a secure channel, HTTPS. So we developed HTTPS, but nobody was thinking about it from the terms of how does this enable businesses today? Will that enable a Facebook or an Amazon? No, they emerged over time. And now we are at a point where we say, you know what? HTTPS alone is not enough. We need the next layer. We need something that negotiates not just a secure connection, but that negotiates whether I can trust the other party. Because a secure connection to an untrusted party is not going to help me in business. So we need to build another layer on top of it. And that's how we think about those standards that we're developing mostly in the specification projects of the Eclipse Data Space Working Group, like the data space protocol, the decentralized claims protocol, and so on, as that is the layer that enables us to exchange information about trust between two parties. It doesn't say whether that JPEG sent to the web browser is a cat or a dog or an image of a house, because that is not relevant at that layer. So basically what it does is just say, you have an attribute in one of your trust frameworks, your driver license, your passport. This is the standardized way how you get it from A to B. At this point, it's all a big Jedi mind trick. There are no data spaces, because we are building something that's like the internet, a collection of independent nodes that speak the same technology. Only when they get to the next layer above, then communities and data spaces, in the sense that most people talk about it from a business and political perspective, start to emerge. So when I have a participant that has a data space connector following those protocols, then that is like a human with a browser. You can have one tab open on the business model of Amazon, the next tab open on the business model of eBay, the third tab open on your favorite local online shop, and so on. They are all using the same protocols, HTTP, HTTPS, and HTML as a semantic model, but they're differentiated in their business model. So the business model is the economic layer here. Do I have a data space for a supply chain that has specific rules for supply chain companies? Do I have a data space for automotive? Do I have a data space for energy data? And is that within a certain legal domain? So think about, again, Amazon as an online shop selling in a lot of European countries, but still being required to follow the local legislation and local regulation. So Austria is a very small country. We have been just appended to Amazon Germany, but with some sub-rules. Like if I have an account in Austria, I cannot buy wine on Amazon in Germany, because they say, sorry, too much regulation. We don't want to deal with this. We just don't sell alcohol to Austrians, period. And the same thing will happen in data spaces, where, look at the Green Deal data space. It will have to exchange data with Chinese companies, because a lot of the participants have suppliers in China. Now, the Chinese government says, no, wait a second. We like your Green Deal because our companies get a lot of business from that, but we are not going to send you all the nitty little gritty details of the data. There's a Chinese law in place that certain manufacturing data you're only allowed to send outside of China if they're in aggregated form, because you could have too much competitive advantage if you get it all little details. So we need to find a model where a Chinese company can participate in a European data space technologically, but also has the possibility to decide or manage the data in a way to fulfill both legislations. And that's an interesting way to think about data spaces, because we can only do that when we bring trust frameworks into the mix. And the trust frameworks, and I say multiple now, although we are here with one very specific trust framework, iSHARE is a great model, but there will be people that say, I do not accept iSHARE purely for the fact that it's European. A Chinese company will have to follow whatever trust model the Chinese government puts on them. We have already trust models emerging in Japan, in Brazil. And those guys will say, well, but we need a way to communicate with each other. If I say you're not allowed to forward this data to a third party, how do I express this so that no matter if I use iShare or if I use Uranus in Japan or whatever the Chinese thing is called, so that people can understand that? And that's in the technical layer. We have basic semantic models for that. So the same way that in a web browser, if somebody sends you a JPEG, your browser knows that they should load the image rendering part. we have something that says, oh, this is a policy for a data right, or this represents a certification, an attestation, a self-description. And those standards is what hopefully will help resolve this picture of the throwing spaghetti at the wall and the primordial soup of data spaces. And that together then forms this layer cake of data spaces. So looks very much like an engineering slide. I'll try to make it simple. We have the base protocols. The data space protocol is, think of it like HTTP on the web. It just helps you to find the data and to negotiate the contract of where the data is allowed to move. On top of the data space protocol, we need to have other protocols that allow the negotiation of trust in terms of exchanging trust. So what does that mean? How do we as humans create trust? I have a mental model, maybe subconscious, not conscious, of when do I trust another person? And then when I meet somebody, my brain goes through that mental model and says, oh, that person works for IBM. Yeah, maybe I trust them a little bit less than the guy that works for Google over there or something like that. And we want to do the same in a data space. We say, I am willing to publish my data to other parties that I do trust. Here is my list of policies that need to be met to declare trust to that other party. Then the other party knocks at my door and says, you don't know who I am, but I want your data. Here is my bag of evidence of what I am, what my claims are. Match that against your policies. And that could be something like, oh, I'm an Austrian company. Here's my EIDAS. Here's a certification that I am ISO 27001 certified, and so on. There could be hundreds, if not thousands, of such policies and claims attached to a single data asset. And the decentralized claims protocol is basically the protocol that enables the reconciliation of here is my policy requirement to declare trust versus here is the backpack full of evidence that they fulfill that trust from the counterparty. And that it does not say what the elements are of that trust. It just says, how do I match an evidence to a policy that I have? So what we need is a vocabulary. How do we express that, what I want to prove? And that vocabulary is generally the trust framework. But since I just explained that we're expecting multiple trust frameworks to exist in this world, similar like you have multiple root certificates in HTTPS to create security, we expect that a lot of trust frameworks will emerge. Some will be more dominant than others. Some might exist just in a very specific niche, like for one specific industry in a specific part of the world. But they all need to agree on a couple of things. They need to agree on a vocabulary. How do I express conformity? So what is a certificate? What is an assertion? What is a self-attestation? And so on. Those things we are standardizing in the conformity assessment policy and credentials profile. Long name, just call it CAP, that's fine. And the other thing is, if we want to have a basic vocabulary on data rights, like do not forward, do not use for AI training, things like that, then we need to agree on a base vocabulary for data rights, and that's the data rights and policy profile that we have. And with that, the trust framework then can build its specific implementation of that. And on the very top, then the data space projects can take advantage and use all this standardized cake. So I hope that kind of gives a bit of a glimpse of how standardization works and why it's so complicated, because essentially we are building the idea of the next layer of the World Wide Web. And if you look at how complicated the World Wide Web is and how we need to be very careful that this does not promote only one business model, but leaves innovation open so that future business models can emerge. If back in the 70s, the World Wide Web would have been built in a way to accommodate a future online shop, they would probably have designed the protocols differently. But then when you look at what new business models emerged through the standardization of the World Wide Web, the open innovation is what we're looking for data spaces, because data spaces will enable exchange of data in a trusted way at a much, much faster pace than humans can do it. And that will also automatically lead to new innovation, new business models that we don't even understand today or cannot even predict today. And yeah, so I'm getting the side eye from Gerard, so I'm talking way too much. Let's be really quick about the open source part here.
Yeah, just go a few more minutes.
So
it's between you the lunch.
Oh, sorry, I'm between you and lunch, so you will really hate me for this now. But let's be quick. So the way we look at open source is we're saying if this works like the World Wide Web, then the fundamental technology behind that will eventually end up in open source. So let's speed these things up and build stuff in the open source right from the beginning. Some of you might remember a company called Netscape and the browser called Mosaic, and that was originally started as a for-profit business, but today nobody is thinking of a simple HTTP connector as a for-profit business. Every software just is connected to the World Wide Web, right? And so that's why we want to build that from the beginning in open source to enable as many companies, as many organizations as possible to use the standardized technology. And also because we want to build this in a democratic, meritocratic way, which means if you are a company or an organization that takes huge dependencies on data space connectors, on data space technology, please come to the table, join us in the open source projects and help us shape it. This is not, I'm going to my favorite software vendor and say, please sell me 5 licenses of data space. This is democracy. This is free beer, and not like free beer, but like free speech. So you're not going somewhere to get free software. You're going there to participate in shaping the software. And so the core project is the Eclipse Data Space Components, which is, let's say, a building block system of elements that you might need when you build a data space. So that could be some component that negotiates the data sharing contract, a component that gets access to the data catalog, a component that helps you exchange verifiable credentials from all kinds of wallets, and so on. And so the main components that we have in there basically cover the standards that are defined in the specifications. So that if you are building a data space product, you don't need to go and read the hundreds of pages of standardization. You get an open source component that implements the standard exactly the way how it is specified. And then you just build the business value on top of that without having to redo everything from scratch. And of course, there will be use cases and companies that do not want to use the open source code because they want to have a different implementation, have it on a different technology, have some custom thing built on top of it, and that's fine. They can always go back to the specification and implement everything from scratch. For everybody else, it will be easier to go and reuse the components from this open source project. So as we've started this project in 2021 with originally just the data space of Gaia-X participating, but it now has been adopted by the majority of the data space projects. And it's it's growing really fast. It's implementing everything we have in the standards, lagging behind always a couple of weeks because, you know, first you need to write the standard, then you need to agree on the standard, then a developer can build it. But this is a project where you basically are the closest you can be in executable code to what the standard says on paper. And we see that EDC is going to be used in the simple project as well. We are working on having a native integration with the existing iSHARE satellites into EDC. That is a project that we have the architecture for, we just need more helping hands to write the code. So it's all a bit dynamic. If it doesn't feel professional, well, we are trying to fly the plane while we are still building the wings, which physically doesn't really work that well. So we need a bit more helping hands to finish the building faster. And if you want to help us with that, here's a couple of links of where you can get engaged. Have a look at that. Depending on where in the layer are you interested in contributing, the technology, the business models, the actual code. We have a place for everyone, and everybody who has two able hands and a good mind is welcome to participate in the project. And sorry for keeping you from lunch so long.